And what we're going to do actually is do clustering twice. The first thing we do is we're going to cluster in that big feature space I was just showing you. And those clusters are going to be referred to as textons. Now this is a word, I think it's a word that was coined by Bela Ulrich, who was a psychophysicist, guy who did random dot stereograms quite a while ago. And they were referring to things like T-junctions and little end stops and other textural descriptors that existed in images as sort of he saw them. And the idea is that these clusters in the feature space would be different little textural elements that were found in these images, right? And so you would describe each little window, okay, by what's referred to as its texton histogram. That's what this thing is going to be showing here. We'll take a little bit more of that. But the idea is that here there is just a single value at every pixel, which is the single texton that tends to be present at that pixel. That is, which cluster it got mapped to. And you can see that, you know, if you were to just cluster based upon this, it would be kind of weird because, yeah, this is not one nice thing because it's a single texture. But the idea here is that even though this is a single texture, there are all these different little textons that are present. So instead of segmenting the image based upon which single cluster you're mapped to, instead what we're going to do is we're going to take little windows. So here's a little circular window, and we compute its texton histogram. Okay, so now we've got a whole bunch of different textons, and this is the count of the number of those textons. So I get a histogram at every window. So here's another window, and it has kind of a similar histogram. And here's a third window. Well, its histogram looks nothing like that. And the idea is that you're now going to cluster in the histogram space of these textons in order to be able to get your segmentation. All right? And how well does that work? Well, let me show you an example. So here is a picture of a rhinoceros. No, a zebra, I guess. I don't know. Thing with stripes. Okay? So suppose I cluster it based upon color. What would that look like? Well, it would be a mess. Okay? And there's your mess, color-based regions, and you'd say, well, that's a terrible idea.
That's a terrible idea.
So what would be a better idea? Well, how about we cluster based upon texture? And you can see that you get these broad clusters that seem to do, you know, reasonable job. I mean, it does make the entire, you know, this region here, which is sort of this big region there. You'll notice that it's not, you know, because of the scales that got used, in this case, it didn't find these legs here or this one there. But that's a function of sort of how you go about describing it. And I will say that in general, this is kind of an under-segmented result. There probably should be more segments. But clearly, this is way better than this color-based approach because it allows us to describe the texture.